Hi, this is Steve with iFLOW. Welcome to our video series. In this segment, we're going to get a little closer to the unit. In this segment, I want to look at the wiring and the controls that are included on the iFLOW PCB. Because we need to get close, I wanted everybody to get a good close view of the unit. We're in a little bit of a tight situation here, trying to get in. And then use some of the presentation. So I'll slide the computer in and out, but we'll do our best. So with regards to the iFLOW controller, there are a number of different components. Just a general look, you've got the display in the center, and the control for the display. You've got to control the display, you've got 4 buttons below. You've got the mode button, you've got the enter button on the right, and then up and down in between. So mode goes through the 6 modes. When you want to enter mode, you press the enter button and then use the up and down to scroll through the different parameters in the system. So that's easy enough. So that's the control board, or that's the display. In addition to the display, you have all of your inputs. So this is a 2-zone board. So we've got our thermostat inputs here. So we've got our outdoor sensor, our flow sensor, our thermostat 1, thermostat for zone 1, thermostat for zone 2. On the bottom, we have our zone dampers. So if we're using zone dampers, your zone dampers for zone 1, your zone dampers for zone 2. On the right, or sorry, on the left, we have outputs. So we have a circulator output, dehumidifier, humidifier contact. We have a heat pump for the reversing valve. We have those connections, and we have your AC compressor outputs as well, all on the right side. Above, we have our power wiring. So we're bringing our 120 volts into the unit at L and N here. We are driving the pump. So we have onboard variable speed pump control that we will power from the C1 and N contacts here on the power strip. And then we'll go through some of the other sensors that we have on the unit. We have on the coil, we have our hot water supply temperature sensor, our return water temperature sensor. Above the coil, so when you open the unit, we have an AC evaporator temperature sensor that's going to be sensing the temperature on the top of the AC coil. We have a supply air temperature sensor that is above the coil, and I'll show you a picture of that in a moment. We have a humidity sensor here that's looking at the humidity of the return air. We have an outdoor sensor, which is this black wire connected. We have our return air temperature sensor, and then we have a dehumidifier, a DH evaporator temperature sensor, which is used when we're using heat pumps to detect the temperature on the suction line close to the evaporator to determine when the reversing valve is operating, but we'll look at that as well. So those are a lot of the connections that we have on the board. So let's look at them in a little bit more detail. And for that, I'm going to kind of slide the computer in. So the iFLOW is likely going to be the most advanced HVAC controller that you see, and as such, and you can see by the wiring of this 18,000 unit, that's our 4-zone system, but you can see all the wiring. We have our outdoor sensor, we have 4 zones of wiring, we have 4 zones of dampers, and then we have some of our outputs on the left side. There are many built-in features and functionality that you need to be aware of so that you can properly wire all of your components to the iFLOW. The iFLOW does not wire the same as a furnace, and if you don't wire it accordingly, you could damage the PCB. So that's why we want to go through this presentation today to kind of give you some guidance on that. So there are a number of sensors and control sensors and feedback sensors that we use to control the operation of the unit. We have as I mentioned, the supply water temperature, the return water temperature. We have a supply air temperature, return air temperature sensor. We have the AC evaporator temperature sensor that I showed you earlier. We have the DH evaporator temperature sensor for heat pumps. We have an outdoor sensor that is always looking at measuring the outdoor temperature and then calibrating the delivery of BTUs on the inside accordingly. We have the humidity sensor, as I mentioned. We have a communication cable that works with the iFLOW Navion. And then we've got our Wi-Fi module. So those are the items we're going to look at. Some are control, some are just wiring, so it's kind of a mix of wiring and control. So first off, the supply water temperature sensor. Again, that's this red wire that's connected to the hot inlet pipe on the unit. It's reading the incoming water temperature from the heat source. During a call for heating, it's looking for a temperature of 90 degrees or above to be able to start the blower. If the supply water temperature from the heat source is below 90 degrees Fahrenheit, it's going to wait until, it's not going to turn on the blower until it gets that temperature, because it doesn't want to blow any cold air into the space. Then the difference between the input and the output, right, the supply water temperature and the return water temperature, gives us our delta T. And with that we can look at adjusting either the flow rate or the CFM rate to kind of maximize the delta T across the coil to ensure you're getting great efficiency. The return water temperature, basically it's this black wire with the copper sensor, and that is connected to the return pipe. So as the water leaves the hydronic coil and goes back to the heat source for reheating, again, it makes up part of the team that gives us the delta T. And anecdotally, the return air temperature sensor is somewhat related to the supply air temperature. And then on the heating equipment, if you're using a gas-fired boiler or tankless water heater, it will be relative to the exhaust stack temperature as well. So this is where we get into the system analysis and system review. Number 3 is the supply air temperature sensor. So first of all, if we go back, the supply air temperature, the return air temperature, the supply water temperature, the return water temperature, all connect in one harness at the top of the board, the top center of the board usually, and you can see the various wiring in the display. So now we get to the supply air temperature. The supply air sensor temperature is located on the top of the coil, and I can give you a little bit of a visual, I think. So if we come up to the top of the coil, you can see this is the supply air temperature sensor, and then the evaporator temperature sensor. So when you open the unit, that's what you're going to see. This is already prefixed. This will strap to the top of the evaporator coil. Okay, so that is the supply air temperature sensor. So that's going to be attached to that harness right on the top of the hydronic coil. It's going to measure the air coming off the top of the coil on a heating call. The return air sensor is actually located in the next to the blower, kind of in this lower area, just to the left of the blower as you're looking at it from the front, in the harness that's coming down from the board, all wired together. And it is looking at the return air temperature and deciding how much heating or cooling needs to be delivered into the space. Just one note, and we'll look at this a little further. If you're using an AC coil on the return, then we will need to relocate the return air sensor upstream of that. And we'll look at that a little bit more closely with some diagrams to to solidify that point, but all to say, mention it here, when you're using the return air sensor, you do want to, or if you're using an AC coil on the return duct, you'll need to relocate that return air sensor. The AC evaporator temperature sensor, as I mentioned, it can be in copper or in stainless. The settings are the same. The capabilities are the same, just different models. It's there reading the temperature coming off the top of the evaporator coil continuously, and when that temperature, so this will be strapped, let's say, to the top of your evaporator, when it sees a temperature of 37 degrees Fahrenheit or 3 degrees Celsius or below, it is going to actually interrupt the call to the AC compressor. That will stop the overfreezing of the freezing of the evaporator coil, and it will also provide freeze protection to the hydronic coil, because you can imagine if the AC coil on top is starting to freeze up and that ice is building down towards the bottom of the coil, as the condensate drips down that way, that's getting very close to the hydronic coil. And if you have any buildup of ice on the hydronic coil, the transfer is very, very quick, and you can actually damage some of the hydronic coil. So the freeze protection is critical, and that's what this outdoor sensor is for. It's providing freeze protection for the AC evaporator, but also, and more importantly perhaps, the AC or the hydronic coil that's below the AC evaporator. If you do not relocate that sensor, then you do not have freeze protection, unfortunately. So when you have this sensor, you can insert it into the fins of the AC coil, or you can strap it somehow to one of the elbows at the top. You just have to make sure it is actually reading the air temperature coming off the top of the coil. When we are using a slab coil on the return duct, then we have to relocate the sensor from the top, because this is, it's at the top of the unit, looking to normally run with an AC coil on top of the unit, on the supply, but in this case where we've got the return, it has to measure the temperature coming off the coil, so we have to look at the airflow. So if the airflow was coming this way, this sensor would be downstream of that airflow, so it's properly sensing the air temperature coming off the coil. And again, that can fit into the fins of the slab coil as well. So in terms of position of the evaporator temperature sensor, again, on an A coil on top, it will fit somewhere towards the top of the unit. If you're using a slab coil on the return, then it will be downstream of the coil, so between the coil and the evaporator and the iFLOW, when you're using it on the return slab. If the wire harness is not long enough to reach when you're relocating it using a slab sensor, then you can use any thermostat wire to extend it without problem. So as I said earlier, when we do that, there are two things. So if we're using a slab coil on the return, then, well, let's go to the regular system first. So if we use a case coil on top, then we'll use our evaporator temperature sensor, strap it to the top without problem. So the return air sensor is seeing the proper return air, and then the sensor is located properly on the top of the AC coil, and it's all good. When we use it on the return, then we have to relocate the slab, the evaporator coil is going to be here. So the return air temperature, if we don't relocate the return air temperature sensor, which is normally located on the blower, it's going to see the already conditioned air. So imagine if you're calling for air conditioning, the unit will start up, the compressor will start, you're delivering cold refrigerant to the coil. So as the air passes across it, it's going to cool, and the return air sensor, which is located on the other side of the blower, is going to see that already cooled air. So you're calling for air conditioning, but the return air sensor says, well, this is the air coming in is already very cold, so I don't need air conditioning. So it will actually turn your system off, kind of as a freeze protection, or a almost detecting an error, if you will. So we need to relocate our return air sensor upstream of the slab coil on the return. So in that case, when we put this into the duct, let's say upstream of the coil, then the return air is going to be drawn in. The sensor is going to see the actual correct room air temperature that's coming back. It will then go through the hydronic coil, cool appropriately, and then the AC evaporator temperature sensor is actually going to see that chilled air, and then the system will work properly. So when we're using a slab coil on the return, it's important to relocate not only the evaporator temperature sensor, but also the return air temperature sensor. And again, both can be extended using temperature or thermostat wire. So again, the purpose of this AC evaporator temperature sensor is to interrupt the compressor when the air temperature coming off the top of the coil is close to freezing. Again, 37 degrees Fahrenheit, 3 degrees Celsius or below. If we have wired the thermostat, as you see in the right here, if we've wired our thermostat like so many contractors do, because that's the way they've done it on the furnace, then we're going to get the call for cooling from the thermostat, and it's automatically going to then send out the signal to the compressor. When our sensor sees a temperature that it says, hey, this is getting close to freezing, I want to turn off the compressor, if we've wired it this way, it is impossible to turn off the compressor because it's getting its signal from the thermostat. So this is incorrect, and you will not have freeze protection if you wire it this way. We instead have a dedicated AC output on the left side, where we have our Y1, Y2, and then common output. So this is a 24 volt output to our compressor. So do not wire your compressor to the thermostat connection on the iFLOW. We have a separate output dedicated specifically for the AC compressor, such that we can interrupt the sensor. So when the sensor sees temperatures that are close to freezing, and to protect the hydronic coil, we'll stop the compressor by stopping the 24 volt output at this contact. So you wire your thermostat as you would normally, and then wire your AC output to the compressor from the dedicated output on the right side of the unit. It could be right side, could be left side, depends on the model. In this model that we're looking at, the 2-zone board, it's on the left side, and I'll show you in more detail where that is. Okay, then we have a DH evaporator temperature sensor. This is looking at the temperature. This will connect on the unit. It will connect with this black harness just above or just below the lower left corner of the board, just kind of above the blower. So that's where it's located inside the unit. And then it's going to wire and connect to the suction line just close to the evaporator. And what it's going to do is measure the temperature on the suction line. So you will actually, you'll probably use some tape or some sort of harness and strap it on to your suction line outside, but in this similar way that we are doing with those sensors. When you get a call for heat and we're using a heat pump, we're going to look at the suction line temperature. When it reaches 90 degrees, then we know that we're supplying sufficient heat to the evaporator coil. and then we will bring on the blower to deliver heat into the home. If the temperature on the suction line does not reach 90 degrees, just the same as if the temperature coming into the hydronic coil doesn't reach that temperature, we're not going to start the blower because we don't want to be delivering cold air into the house. The other thing that the DH evaporator sensor does when it's measuring the temperature on the line, and you can imagine, we're supplying heat out, you know, let's say above 90 degrees, so maybe 100 degrees, 110 degrees into the evaporator coil, and then all of a sudden the heat pump has to go into defrost mode. Well, it's going to switch to AC, so the reversing valve is going to change. The temperature on that line will change immediately, and that's when we know that we're going into defrost mode. When the heat pump goes into defrost mode, as we detect by the evaporator temperature sensor, then we will bring on the pump, the hydronic pump, and we'll bring hot water into the coil and bring the blower on so that we can actually deliver heat into the house while the heat pump is in defrost mode, but also that heat is going to go into the evaporator, and we're going to be able to shorten the defrost cycle time. So the DH evaporator sensor is critically important when we're using a heat pump. The system will not work without it. We don't include it in the box because at this point most of the systems will be installed with regular air conditioning and not necessarily heat pumps. So it is an optional item, but all to say, if you are wiring the iFLOW or combining the iFLOW with a heat pump and let's say a gas backup system, either a tankless or a tank or a boiler perhaps, then you will need to order the DH evaporator sensor to make your system work. In terms of the connection of that sensor, as I mentioned, it connects to the suction line on the line set feeding your evaporator, and then connects back to the unit. The next sensor is our outdoor temperature sensor. The outdoor temperature sensor connects to the board at the upper right corner, and I will show you that contact. And what the outdoor temperature sensor does is it measures, of course, the outdoor temperature, but then feeds that back to the unit. And with that temperature, the unit can then decide at what BTU level does it need to deliver into the home, depending on the outdoor temperature sensor. So, for example, this is our 18,000 unit. We see we can go as high as 95,000 BTUs. So we decide, okay, at what temperature, what outdoor temperature do I need my maximum demand? So we look at our heating load plans or our heat load calculations and say, okay, if our design temperature is -15 and that's where we need 95,000 BTUs, then I can set that. So I will set my temperature, my outdoor temperature where I need maximum BTUs, I will set it at that temperature, -15 Celsius or 5 degrees Fahrenheit, for example. On the other side, we've automatically set this point in the slope. Basically, we're saying at 70 degrees and more, you don't need any heating. So below 70, then you will need some heating. And then between those 2 points, we actually get a slope. So we create a slope between those, and that will deliver different temperatures. So for example, if the outdoor temperature is 45 degrees or 7 degrees Celsius, then we're going to be delivering, go up to the curve, about 35,000 BTUs. If the temperature outside is 20 degrees Fahrenheit or -7 degrees Celsius, then we go up to the curve, go across, about 70,000 BTUs. So all to say that we will vary the amount of BTUs delivered based on these two set points. Now, based on this set point that you're both the BTU input and the outdoor temperature where you need that maximum demand. So, why do we need the outdoor reset curve? Well, it's important because most of the year you don't need maximum demand. Even though we can deliver 95,000 BTUs, most of the season you need much, much lower than that. So why run at 95,000 when we only need 40,000 or 50,000 BTUs? And that's what that outdoor sensor does. We can then adjust the position of that curve. So for example, let's say you're using the 18,000 series unit that's capable of 95,000 BTUs, but perhaps you only need 50,000 BTUs. Well, we can adjust that maximum down to 50,000 BTUs, and we use that using our parameter 14 in the heating section. Right, we have the building's total heat loss. So at that parameter 14, we would adjust from 95 down to 50. So we're basically adjusting, right? You know, a slope, we've got the rise and the run. By adjusting from 95 down to 50, we're lowering the rise. We're lowering the rise. We're flattening the curve. And then with the run, let's assume the run is the same. So we need, you know, we're living in the same area, so the outdoor temperature where we need maximum doesn't change. Now, it could change depending on where you are. If you're in California or Texas or Florida or Nebraska or Minnesota, or Alberta, Yukon, Ontario, depending on where you are, this number will change. So that will skew the curve this left or right, and then your heat loss will increase or decrease the rise, such that we get a different slope. So when we program in that lower input, we see that it actually changes the slope of the curve significantly, and that will change the amount of BTUs we deliver significantly. For example, using that same temperature design, the 30 degrees outside or -1 Celsius, if we did not adjust the maximum input at parameter 14, then we'd be delivering 57,500. But because we've lowered the slope of the curve by inputting our actual correct heat loss for that specific house, now we're only going to be delivering, at that same outdoor temperature, we're only going to be delivering 27,500 BTUs. So this is the value of the outdoor temperature sensor and why you should basically install it with each job and adjust it properly for each job so you can tailor the performance to each job specifically. So really there is no oversizing. We can put any unit in and then adjust the slope of the curve to determine the BTUs that we're delivering. The outdoor sensor connects to the upper right side on this board in a contact called OD for outdoor. It could also be OTS for outdoor temperature sensor. So there are a couple of different acronyms that we've used. And then below that you have the flow sensor. And the flow sensor connects and just gives us domestic priority. So if you want domestic priority and you're installing a flow switch, it would connect to those two contacts. The next is the humidity sensor. So the humidity sensor has a yellow, kind of a dark yellow connector. It connects again to the wiring harness just below the lower left corner of the board, kind of just above the blower. And then the wiring harness, or the sensor itself, is the black end, and that will detect the humidity of the return air. On our control, in mode 3, general parameters number 3, we can actually set the humidity level that you want. So if you want 45%, that is our default, then when the return air, when there's a heating call, the return air comes in, the sensor will look to see what the humidity level is. If it is below your set value, then it's going to send 24 volts out to the humidity humidifier contact. That's on the left, that's one of our outputs here, and it's going to call on your humidifier. So that's the humidity sensor, again, all built into the iFLOW.